Okay, and we are live. So welcome. I have two people who are in right now. If you could say hi in the chat so I know that you can hear me, that'd be great. Okay, those of you who are in the live stream right now, if you could drop in the chat that you can hear me, please. Hey, George. Thanks for joining. Looks like you're the only one so far. All right, so we're just going to get started. Let me go ahead and share my screen. Okay. Can you see my screen now, George? Just give me a thumbs up in the chat if you can see it. Perfect. Okay. Oh, it looks like we got a couple more people joining in here. Welcome, guys. So those of you who don't know me, I'm not sure who is joining in right now, but if you are not in my class, I'm Mr. Sievers. So welcome to Algebra 1 Regents Review. This is the first time that we've had a formal Regents Review session so far this year. As your teachers have probably talked to you guys about, I know I've talked about it in my class, our Regents exam this year is earlier than usual. So our Regents exam is going to be June 4th, which is about a month away. So we have to start reviewing ASAP, which is why I'm doing this live stream. Okay. So the first thing that I want to let you guys know about is the reference sheet. Okay. So I know in my class we've looked at a reference sheet for the old Regents exam, which is attached to this packet that you picked up from me. This reference sheet here is actually not the reference sheet that you're going to get on this Regents exam, okay? Your reference sheet is going to look something like this. Okay, so this says it's a specific reference sheet for Algebra 1, okay? So it gives us a lot of equations that are useful to us. So we have, a quadratic equation, the quadratic formula. There's a couple things like axis of symmetry that we haven't learned yet, but we are getting to soon. And then we have the slope formula, linear equation, slope intercept form, and so on. Okay, so we're going to refer back to this reference sheet a lot. But for today, because I'm working with an old Regents exam that does not use that reference sheet, we're just going to use the one that's attached to our packet for today. Okay, so let's just jump right into this. All right, so number one says, the graph below represents a dog walker's speed during his 30-minute walk around the neighborhood. Which statement best describes what the dog walker was doing during the 12 to 18-minute interval of his walk? So I'm going to mark on my graph where between 12 and 18 minutes. So here's 12 minutes, and here's 18 minutes. Okay. I notice that the line that's in between these 2 points is horizontal, right? It's not increasing or decreasing. So that means that it's a constant rate. That means that there's no change to it, okay? So there is no change. So his speed here, we can actually find his speed by looking over at the y-axis, and it looks like he's traveling at about 1.5 miles per hour. So taking a look at our answer choices, we have he was walking at a constant rate, he was increasing his speed, he was decreasing his speed, or he was standing still. So I'm going to drop a poll in the chat, and I'm going to ask you guys to please take your best guess at what you think the answer is going to be. So A would be 1, B would be 2, C would be 3, and 4 would be D. Give us another couple seconds to think about this. Think about what this means when it says no change. If our graph is it looks horizontal. Okay, those of you who answered A, you are correct. He was walking at a constant rate because there was no change there. Okay, number 2. Given the relation 0, 4, 2, 6, 4, 8, and x 7, which value of x will make this relation a function? Okay, I want you guys to drop in the chat. What does it mean, or how can I tell if a set of points is a function? What's the rule? Go ahead and drop your answers in the chat. What do we think? How can we tell if a set of points is a function? Yes, George, you are correct. As long as no x values repeat. So I'm going to go through my answer choices here, and I'm just going to cross off all the x choices, or all the x values that are already used in our set of points. So this first point, 0, 4, we cross off 0 because 0 has been used. 2, 6, we cross off 2 because 2 has been used. And then we have 4, 8. So I'm going to cross off number 4, which leaves us with answer choice number 3. So you might be asking right now, well, why is it 3 when 6 was used in this point right here? Remember that a point is in the form x, comma, y. So we're just looking at that first value of each of these points. Okay, we're trying to find the one that does not repeat. So in this case, we have 6. Let's go ahead and turn the page. Okay, it says the Speedy jet ski rental company charges an insurance fee and an hourly rental rate. The total cost is modeled by the function r of x equals 30 plus 40x. Based on this model, which statements are true? So there's a couple important things here. First off, we have an insurance fee and an hourly rental rate. So whenever we rent anything from a company, or if a question comes up that's talking about cell phone plans, there's always going to be some sort of one-time fee, okay? And you'll usually tell if it's that one-time fee if it says the word fee, okay? So this only happens one time. Then when it says an hourly rental rate, this rate means that it happens every hour. Okay, so we're being charged an hourly rate. So given the function r of x equals 30 plus 40x, let's kind of connect the insurance fee and hourly rental rate to this function. Okay, so the constant value of 30, this only happens one time. So this is going to be the insurance fee. Okay, and then this 40x, this x tells us that that's going to be the number of hours. Okay, so it's going to cost us $40 for every single hour that we rent the jet ski. Okay, so looking at our answer, or these options here, the first one says r of x represents the total cost. Number 2 says x is the number of hours rented. 3 is $40 is the insurance fee, and then 4 says that $30 is the hourly rental rate. Okay, I want you guys to take a second, look through these answer choices, and then answer the poll with your best guess. So we're trying to figure out which of these statements are true. So number 1 says only the first one is true. Number 2 says both of them are true. Number 3 both 1 and 2 are true. Number 3 says 1, 3, and 4 are true. And then 4 says all of them are true. So what do we think? Which of these statements are true? It's okay to take an educated guess if you are unsure. George, you're struggling. Okay, so let's think about what this one-time fee is. Okay, so the insurance fee happens one time. So which of these two values do you think is going to be the insurance fee? Go ahead and drop it in the chat, George. Is the 30 or the 40 going to be the insurance fee? It would be the 30, yeah, because that number was only added one time, right? So if 30 is the insurance fee, then obviously statement number 3 can't be true. What do we think this 40 represents? Go ahead and drop that in the chat. Yeah, it's gonna be the cost per hour. So that means that X, the variable that's attached to the 40, would be the number of hours, right? So number 4 can't be true because we just determined that $40 was the hourly rental rate, so we can't be number 4. So far, I agree with number 2. And then R of X, this says it represents the total cost. And I agree with that statement because this says that R of X equals this function, right? So no matter how many hours I rent the jet ski company, or the jet ski from the company, R of X will tell me how much my total cost is. So in this case, our answer choice is 2. Does that make more sense, George? Just give me a yes in the chat. Okay, I'm not seeing any more responses, so let's move on to number 4. Okay, it says the 11th term of the sequence 3, -6, 12, and -24 is what? What's the first thing that we notice about this sequence? Go ahead and drop your answers in the chat. There's one thing that I noticed right away. Does anyone know? Okay, so taking a look at these 4 terms, it says we have +3, and then we go to -6, +12 to -24. So what's happening is that it's alternating from a positive term to a negative term, right? So in order for that to happen, there's only one type of sequence that can alternate the signs of each term in the sequence. Is it arithmetic or geometric? Let me create a poll real quick. So it's either arithmetic or geometric. What do we think? Is this sequence arithmetic or geometric? Okay, I got 1 vote. Give another couple seconds for the other couple people. Do we think that this sequence is arithmetic or geometric? Think about the alternating signs as we progress through the sequence. Okay, so in my class, when I taught sequences, the word that I associated with arithmetic was adding. So whenever we add the same number each time, it's going to automatically tell us it's an arithmetic sequence, okay? If I try to add the same number each time to go from 3 to -6, I'm going to have to add -9 or subtract 9. But that if I did -6 minus 9, does that equal 12? No, that's going to equal -15, right? So this is actually going to be a geometric sequence. And it wants us to find the 11th term of the sequence. And if you're thinking right now, I don't remember the geometric formula, good thing we have a reference sheet. Okay, so on the back of your Regents exam, I want you guys to find where it says geometric sequence. Let's put a star next to it. I'm going to use this formula right here to help me find the 11th term in the sequence. Okay, so that formula is a sub n equals a sub 1 times r raised to the n minus 1. A sub 1, this represents our first term. Okay, so I'm just going to go ahead and substitute 3 in for a sub 1. Okay, we have to find r. R is the common ratio. So what number can I multiply by 3 to give us -6? And then what number times -6 will give us 12? What number times 12 will give us -24? Go ahead and drop your guesses in the chat. What do we think the common ratio is going to be? Remember that ratio is multiplying. So what number is going to be? Yes, George, it would be -2. Perfect. So we're going to plug in -2 for r. And then we have one more variable left in our formula, and it's n. N is the term number. So because it's asking us to find the 11th term, I'm going to do a sub 11 equals 3 times -2 raised to the 11 minus 1. And then I'm going to go right over to my calculator, and I'm just going to type this right in. So 3 parenthesis -2 caret 11 minus 1. Enter. And we should get 3072. Okay, so when you see this word sequence, I want you guys to think reference sheet. Go to your reference sheet, okay, and that'll help you find the formula. Number 5, which situation represents exponential growth? So this kind of ties back to question number 4. So a geometric sequence is really the same thing as an exponential function. We talked about that in our classes. So if geometric sequences, in order to get to the next term, I have to multiply by the common ratio. That key word is multiply. So when I'm talking about exponential growth, I'm going to choose an option that is multiplying. Okay, so which of these 4 answer choices do we think is going to represent an exponential growth function? Would it be adding $10 to a jar each week? Would it be growing 1.5 feet per year? Earning $20 per hour babysitting? Or the number of people majoring in computer science doubles every 5 years? What do we think? You got 1 vote. Another couple seconds. So which one of these answer choices would be multiplying? All right, cool. We got 2 votes, and they are both for answer choice 4. And that is correct. The word doubles here indicates to me that we are multiplying or multiplying by 2 every 5 years. Okay, so that multiplication tells us that that's an exponential growth. Number 6. The expression negative x squared plus 3x minus 7 minus 4x squared plus 5x minus 2 is equivalent to what? So whenever we see this word equivalent to, we're going to think that we have to simplify. Okay, so this expression here, we're just going to go ahead and simplify this. So I have a trinomial minus a trinomial. When I have this minus sign in between trinomials, that really tells us that we have an invisible negative 1. What am I going to do with that negative 1? Go ahead and drop it in the chat. What am I going to do with this negative 1? Bentley, yes, distribute. We're going to distribute this negative 1 to all 3 terms that are inside of the second trinomial. I'm going to bring down this first trinomial. So we have negative x squared plus 3x minus 7. And then negative 1 times 4x squared is negative 4x squared. Negative 1 times 5x is negative 5x. And then negative 1 times negative 2 is positive 2. And then we're going to combine like terms. So I have my x squareds. So negative x squared minus 4x squared. This is really a negative 1. So negative 1 minus 4 gives us negative 5x squared. And then I have 3x minus 5x, so minus 2x. And then negative 7 plus 2, which is negative 5. So answer choice number 2. Okay, let's go ahead and turn the page. I'm going to go on to number 7. So number 7 says, if f of x equals x squared, which function is the result of shifting f of x 3 units to the left and 2 units down? So this one's tricky. We have talked about transformations before, or in other words, moving a function, but it's been a little while. So this 3 units left, okay? When we move horizontally along the x-axis, that's going to be the part of the function. So if we have f of x equals, here's my x squared. Whatever number I have inside the parentheses here will determine how I move left to right. But the key thing to remember is that that number is going to be opposite of the direction that we move. So typically, we would think, oh, to the left, that's in the negative direction. But we have to think opposite. So this is really going to be x plus 3 squared. And then 2 units down, this is just moving our function 2 units down. This is going to be subtracting 2 on the outside of the parentheses. So the number on the outside of the parentheses moves it vertically, okay, and we use the normal sign. So the negative 2 means we go down, and then what's inside the parentheses moves it horizontally. So if it's positive, we move to the left. If it's negative, we go right. George, so if it's negative, go right instead, and if it's positive, go left instead. Yes, exactly. Yep, so it's going to be opposite of what we normally think. So in this case, our answer choice is 3. This question was nice because even if we didn't know how to write this 3 units left in terms of my function, if I just look at 2 units down, the only one with negative 2 on the outside is answer choice number 3. But you would have to know that where that minus 2 goes into our function. Okay, number 8. An equation used to find the velocity of an object is given as v squared minus u squared plus 2as, where u is the initial velocity, v is the final velocity, and a is the acceleration of the object, and s is the distance traveled. When this equation is solved for a, the result is what? So you're probably looking at this and being like, I have never heard of velocity or acceleration before, and that is okay, all right? Because I don't need to know any of that information. The only thing that I need to know is how to manipulate or to solve an equation. So I'm just going to go ahead and copy my equation over here on the right. And let me get my highlighter. I'm going to highlight A, because A is what I want to solve for. Okay, so I see that I have two terms on the same side that A is on. Okay, I'm going to go ahead and move the term that does not have A. So in this case is the u squared. So we're going to subtract u squared from both sides. So v squared and u squared, these are not like terms. Even though they have the same exponent, they do not have the same bases. So we have v squared minus u squared equals 2as. Okay, and here's a again. We haven't gotten it by itself yet. So we have 2as. What operation is holding all three of these together? Go ahead and drop it in the chat. What operation holds the 2, a, and s together? Multiplication. Good. So then the opposite of multiplying is dividing. So I'm going to divide both sides by 2s. Yes, George, it is multiplication. So when I divide both sides by 2s, the s's are going to cancel on the right, and the 2's are going to cancel. So then this right here is what a is equal to. So then all I have to do is find that in my answer choices. We have answer choice number 2. Okay, so for this one, we call this a literal equation, and that's when we have only variables and very few numbers, okay? We don't have to know what the velocity, acceleration, or any of that means. All we need to know is the rules of manipulating an equation, okay? Let's move on to number 9. Mrs. Smith's math class surveyed students to determine their favorite flavors of soft ice cream. The results are shown in the table below. So I know that this is the last unit of the school year, so we have not gotten to this question yet, but we're still going to do it. Okay. It says, of the students who preferred chocolate, approximately what percentage were seniors? So it's saying, when it says of the students who preferred chocolate, that means out of all of the students who chose chocolate, what percentage of them were seniors? So percent is going to be part over the total. So in this case, our part will be the seniors because they're a part of the group of people who voted for chocolate, and then the total will be chocolate. Okay. So 42 plus 67 is 109. So that's gonna be my total, and the part 67 for the number of seniors that we have. So we have 67 divided by 109. Let's go ahead and just type this into our calculator. So we have 67 divided by 109. And we get 0.61467888991. This does not look like a percent. But we have talked about how to change a percent to a decimal. So drop in the chat, everyone. What do we think is the percent from this decimal? I'm not going to make a poll for this one. I just want us to find what the percent is. Yes, Bentley, you're very close. Take a look at what our answers are rounding to, okay, and make sure that your answer matches what our answers are rounding to. So I'm looking for 61 point something. Perfect. 61.5. Because this third decimal place here, so if I take this decimal, I move it 2 places to the right. So right now we go from 0.6746. If I move my decimal 2 places to the right, now I really have 67.46, but I want to round to the nearest tenth. So looking at this 6, since it's 5 or above, it's going to tell us the 4, it's going to give it a shove, and it's going to go up to 5. So you have about 60, 67, nope, wait, sorry, 61. This should say 61, not 67. So then 61.5. So George, you can think about it like that. But so if you rounded this answer to the nearest thousand, then you would still have to move the decimal place 2 places to the right in order to change it to a percent. Okay, but it's good that you recognize that. Nice job. All right, let's go on to the next page. Number 10. If f of x equals x squared plus 2x plus 1 and g of x equals 3x plus 5, then what is the value of f of 1 minus g of 3? So this is going back to evaluating functions, right? So our functions originally start as f of x, right? That's the name of the function. But it wants us to find f of 1 minus g of 3. So where does this 1 come in? What do I have to do with that 1? And also, what do I have to do with this 3? Go ahead and drop it in the chat. What am I going to do with the 1 and the 3 that are inside of the parentheses of our functions? This is thinking back to, I think it was unit 3, so it was a while ago. Think about what the 1 replaced in f of x. So we go from f of x to f of 1. So what is 1? 1 is really the value for what? Okay, I'm not seeing any answers, so we must be stuck. That's totally okay. All right, so going from f of x to f of 1, this 1 replaces the x that's inside of the parentheses. Okay, so wherever I see a 1, wherever I see an x in my function f of x, I'm just going to replace that with a 1. And then same thing for g of x. We went from g of x to g of 3. So wherever I see an x in this function, I'm going to replace it with a 3. Okay? So f of 1 is going to be equal to 1 squared plus 2 times 1 plus 1. These parentheses are very, very important. They might not seem important right now because we have positive numbers, but once we get some negative numbers, those parentheses are very, very important. So 1 squared is 1, plus 2 times 1, which is 2. So 1 plus 2 is 3, plus 1 is 4. So f of 1 is equal to 4. Now we want to find g of 3. So I'm going to take a look at g of x. Wherever I see an x, replace it with a 3. So we have 3 times 3 plus 5. So 3 times 3 is 9, plus 5 is equal to 14. And because it wants us to find the value of f of 1 minus g of 3, we're going to do positive 4 minus 14, which gives us our final answer of negative 10. So those of you who forgot, does that ring a bell now that we've gone through that problem? Did we remember a little bit from that? Think you got it, George? Cool. And we're going to review more of that before the Regents exam as well. So, okay, number 11. Which function has the largest y-intercept? So what I want to do for all 4 of these answer choices is just go ahead and write down the y-intercept for each of them. Okay, I'm going to start with this graph because it's probably the easiest to find the y-intercept from a graph, because it's where the graph crosses the y-axis. So in this case, it is 1. What about from a table? So let's think about this point here from a graph. If I go down to the origin, I notice that my x value is going to be 0. So this point is really 0, 1. So the y-intercept happens when x is equal to 0. So looking at a table, when x is equal to 0, 2 is going to be our y-intercept. So in this case, it's 2. Now, answer choice number 1, this is in slope-intercept form. So looking at the new reference sheet that you guys don't have a copy of just yet, we have y equals mx plus b. Remember that this b value is the y-intercept. So looking at this equation, our b value is that constant, which is negative 1. Okay. Now we have g of x equals the absolute value of x plus 3. So going back to that question about transformations, when we talked about the number that moves our function vertically, that's written on the outside of our function, right? So our outside of the absolute value, outside of the parentheses, whatever the case may be. So in this case, my y-intercept is 3. So the largest y-intercept would be answer choice 3. Now the other way that you could do this is graph both answer choice 1 and answer choice 3, and then compare it to 2 and 4. Okay, because sometimes we might not remember how to find the y-intercept directly from the equation, but you can always use our calculator, right? Just type it right into y equals and pull up your graph to find that y-intercept. Okay, number 12. 2 texting plans are advertised. Could I do 1 and 3 in the calculator? Absolutely. Okay, we're going to go to y equals, clear anything out that's in there, and then negative 4x minus 1. I can always get a picture of my graph, but sometimes it's not really easy to tell what it crosses through. So if I pull up my table, I'm trying to find where my x value is equal to 0. So in this case, we see 0, negative 1. So that's how I got this negative 1 here. Okay. Now for answer choice 3, this absolute value of x, math, right arrow, enter, gives us that absolute value. Type in x, right arrow out of the absolute value, and then plus 3, hit second graph, and then find where x is equal to 0. In this case, we see it's at 3, which is what I had right here. Does that make more sense, George? Okay, cool. All right, number 12. So 2 texting plans are advertised. Plan A has a monthly fee of $15 with a charge of 8 cents per text. Plan B has a monthly fee of $3 with a charge of 12 cents per text. If T represents the number of text messages in a month, which inequality should be used to show that the cost of Plan A is less than the cost of Plan B? So let's just go ahead and come up with expressions for both Plan A and Plan B. Okay, so I see that word fee again. That fee tells me that that amount is only going to be charged one time. Okay, so we have 15 plus something. And then it says a charge of 8 cents per text. So this word per tells us that we're going to have some sort of variable attached to that number because it's going to happen each time we send a text, right? So we have 0.08, and then in this case, it tells us that we're going to use T for text messages. Plan B says the monthly fee is $3 with a charge of 12 cents per text. So that monthly fee happens one time. So we have 3 plus, and then the charge per text. So 0.12 T. And then if we want to say that Plan A is less than Plan B, then this is what it's going to look like. So 15 plus 0.08 T is less than, and then just copy over Plan B. And I see that that is answer choice number 1. Okay, let's go on to number 13. The function f of x is graphed on a set of axes below. Which equation of the axis, or what is the equation of the axis of symmetry for f of x? So my class, I know we've only talked about this one time so far this school year. It's going to be in our next unit, which we're going to get to later this week. So the word symmetry, this means same on both sides. Okay, so I want to basically find the line it's a vertical line that goes through this graph that if I folded this graph in half, it would sit directly on top of each other. It's going to look the same on both sides. Okay, so I'm just going to do this one for you guys just because we haven't gotten into it yet. So the axis of symmetry always goes through the turning point of our parabola. Okay, so it's just going to be the vertical line that goes through the turning point or the vertex. Then the equation for the axis of symmetry is just going to be x equals whatever x value it crosses through, or whatever x value the turning point has. So in this case, it's just -1. Okay. Don't be too concerned if you were confused on that one. We haven't learned it yet, and we will get there very, very soon. Number 14. What is the degree of the polynomial 5x minus 3x squared minus 1 plus 7x cubed? So remember that the degree is the highest exponent. So based on that information, we have the highest exponent. Which of these 4 answer choices is correct? Which one represents the degree? Go ahead and answer the poll in the chat. Also, just a reminder, I'm not sure who of my students are in here. I've only got 2 people interacting in the chat right now. So if you want extra credit for being here and you are in my class or Miss Griffin's class, make sure that you interact in the chat so we can get credit for you guys. Yes, answer choice number 3. Perfect. Because this exponent here is the highest one. This is the largest exponent, which is 3. 15. The product of x squared plus 3x plus 9 and x minus 3 is what? So my class, this was actually one of our questions on our weekly review. Okay, so if you've gone ahead, you might have recognized that already. I'm going to go ahead and multiply this using the box method. Okay, so I have a trinomial times a binomial. So horizontally, I'm going to have 2 rows. Horizontally, 2 rows and then 3 columns. Okay, so this trinomial is going to be written on top. So x squared plus 3x plus 9, and then x minus 3 on the left. And now we're just going to multiply each of the boxes individually. So x times x squared is x cubed. X times 3x is 3x squared. X times 9 is 9x. Negative 3 times x squared is negative 3x squared. Negative 3 times positive 3x will give us negative 9x. And then negative 3 times positive 9 will give us a negative 27. Okay, drop in the chat. What do we notice about the like terms that we have? Let me circle our like terms. What do we notice about those? What's going to happen to them? Yeah, they're going to cancel out because we have negative 3 plus 3, negative 9 plus 9. They're just going to cancel out. So then I'm just going to be left with x cubed minus 27. So answer choice number 1. Okay. Number 16. The solution to 2/3 times 3 minus 2x equals 3/4 is what? So when it's saying the solution, this is telling us we want to solve for x. Okay. So to start, typically when I have parentheses and I have a number that's in front, usually I would distribute that, right? But in this case, because it's a fraction in front of my parentheses, it's actually going to make more steps if I distributed that fraction. But there is something that we can do to move it to the other side. Does anyone remember what that's called? I'll give you a hint. We're going to multiply both sides by the same number. What word am I looking for? We're going to multiply by the, starts with an R. Go ahead and type it into the chat. What do we think? Yes, Bentley, reciprocal. And the reciprocal of 2/3 is 3/2. So I'm going to multiply both sides by 3/2. 3/2 and 2/3 are going to cancel out on the left. So that I'm left with 3 minus 2x equals, and then when we multiply fractions, we just multiply straight across. So 3 times 3 is 9, and then 4 times 2 is 8. And then at this point, you might be thinking, oh God, I don't know how to work with it or how to solve for x if I have a fraction. I'm going to start by doing the same thing that I would normally do if this was a whole number. I'm going to start by subtracting 3 from both sides. I'm going to rewrite negative 2x equals. And I'm not going to try to do that in my head because I have a fancy tool that's pretty accurate. So to get the fraction template, you can hit alpha x. So you have 9/8 and then minus 3. enter. And this is going to give us another fraction. So you have negative 15 over 8. And then how do I get x by itself now? What operation? Go ahead and drop it in the chat. What am I going to do with this negative 2 in order to get x by itself? What operation do we think? We only have 4 answer choices. We can either add it, subtract it, multiply it, or divide it. What do we think? How do I get x by itself here? Go ahead and drop it in the chat. Divide, George, yes. Divide both sides by negative 2. And if you have this fraction already in your calculator, don't clear it out. All we have to do now is just click divided by negative 2. And it gives us our final answer of 15 over 16. Okay, we're running a little short on time. We only have about 8 minutes left, so let's keep plugging along. Number 17. If f of x is equal to 2x plus 6 and g of x is equal to the absolute value of x are graphed on the same coordinate plane, for which value of x is f of x equal to g of x? Okay, so this one's a little tricky, okay, because we have to know what f of x and g of x really are. And if we think about this in terms of like y equals, f of x and g of x is really the y values of each of those functions, okay? So I want to find the x value when our y values are equal to each other. So I'm going to go right back to my calculator, and I'm just going to type both of these functions in. So I have 2x plus 6, and I have the absolute value of x, okay? So again, we're trying to find when the y values are going to be the same. So if I pull up my table and I start scrolling along, I'm trying to find where the y column and are both of these y columns where they have the same number. Okay, I see 2 right here. 2 appears in both of these columns, which means that f of x is equal to g of x when x is equal to negative 2. Okay, so this problem is all done in the calculator. Okay, the only thing that we really need to remember is that f of x and g of x is really the same thing as y. Okay. Number 18. What is the solution to the inequality 2x minus 7 is greater than 2.5x plus 3? So this one, let's pretend that this inequality symbol, this greater than sign, let's pretend that's like an equal sign, okay? The only time I cannot think of that as an equal sign is if I multiply or divide by a negative, okay? But we'll get to that. So I'm just going to rewrite this. 2x minus 7 greater than 2.5x plus 3. I'm going to start by moving all of my variables to one side and then constants to the other. So I'm going to subtract 2x from both sides because I want to keep my x term, that coefficient, I want to keep that positive so I can avoid having to divide by that negative number. I'm going to bring down this negative 7 is greater than 2.5x minus 2 is just 0.5x and then plus 3. Subtracting 3 from both sides, we have negative 10 is greater than 0.5x. I can think of this as either 0.5 because this one was written as a decimal, or you could change it to a fraction if that's going to help you. Okay. It doesn't really matter to me what you do. This is supposed to be a decimal. So I'm going to do negative 10 divided by 0.5. We should get negative 20 as our answer. So negative 20 is greater than x. Or, looking at our answer choices, x comes first. So x is less than negative 20. Okay, how are we doing on time? We have about 4 minutes. I could probably get through one more problem, and then I think we're going to call it. Okay. So these three expressions are written below. We have A, B, and C. Which expressions are equivalent to 8x cubed times y to the 6th? So this question has everything to do with exponent rules. Wait, hold on, George, the question, because the sign flips when you divide. The sign flips when you divide or multiply by a negative number when we're talking about inequalities. Yes. Yep. So with these problems here, all we have to do is simplify them. Okay. So exponent rules is something that we've learned progressively throughout the year. It hasn't been anything that we learned like all at once. Okay. So we have to try to pull some information from different spots of our memory. Okay. So we have 2xy squared raised to the third power. So when I have an expression raised to the third power, I'm going to think of this as the cubed almost being distributed to each of the pieces of that expression. Okay, so it's going to be distributed kind of to the 2, to the x, and to that y squared. So this is going to look like 2 cubed, x to the third, and then we have y squared to the third power. So this one I don't think we've seen too much of this year, but if I have a power raised to a power, we're actually going to multiply them. Okay, so we're going to multiply these exponents. I know that 2 cubed is 8, and then x cubed, and then 2 times 3 is 6. So you have y to the 6th. So A works, which means I can get rid of answer choice number 2. Letter B, we have that cubed again on the outside of the parentheses. Let's think about that the same way that we just answered the first part. Let's think of this as distributing the exponent to both the 2 and the x. So this is really 2 cubed, x cubed, y to the 6th. Which we know is, so 2 cubed we know is 8. And then x cubed and y to the 6th. So B works, which means I can get rid of 3. And then letter C. So this one we have an expression times an expression. We know what to do with the exponents when we are multiplying like bases, right? So 2 times 4, we're just going to multiply those coefficients first. 2 times 4 we know is 8. And then x squared times x. Remember, this x here has an invisible 1 as an exponent. So x squared times x to the first power is really going to be x cubed, because when I multiply like bases, we're going to add the exponents, which means that y squared times y to the third power, if I add those exponents, that's going to be y to the 5th power, which is not what we're looking for. So it can't be C, which means that our answer choice is number 1. Okay, so there are still a couple questions that are left. There's about 5 questions left. Feel free to practice those ones on your own. Due to time's sake, I told you guys that this would only be an hour, so I don't want to I don't want to be, I don't want to lie to you and keep you over that hour. So if you have joined, thank you so much for tuning in. I really appreciate the support from my students and my peers and anyone else who has joined in. So I wish you all a great night.